I'm Alexis Badenmare with the Organic Consumers Association and Regeneration International. And today we are discussing a recent meeting at the National Academies of Science. The meeting was called to discuss the breakthroughs needed in agriculture before 2030 in order to ensure that we have enough food for a growing population and that we can farm sustainably into the future. We organized some submissions into that process by Tim LaSalle and David Johnson and Richard Teague. And the reason why we thought that this process would be great to engage in is because Dr. Ratan Lal was already participating as a speaker and a resource in this process. So just to step back a bit, the National Academies of Science, Engineering, and Medicine is actually an independent nonprofit group, but since the days of Abraham Lincoln, it has been called upon by the federal government to come up with consensus statements of the latest science and provide valuable information to governmental decision makers. And it still fulfills that role, and that role is more important than ever, of course, in this current administration. So at this National Academies of Sciences meeting on the future of food and agriculture, there was no restrictions on what the scientists could speak about. So there was an open discussion of climate change and various things that the administration is not getting into at this time. So this was a very important meeting, and we were proud to be part of this in our small way by contributing the value of the scientists presenting on the soil carbon sequestration and food security issues in particular. But let me just share with you real quick the website so that if you didn't see, if you have not watched yet the National Academies broadcast, you can do that. All right, so y'all are seeing my screen. So this is the National Academies of Sciences website, and the town hall event that we're debriefing today took place August 8th. And all of the speakers and panels are now live on the website. So we can scroll down to Dr. Ratan Lal's presentation. And you can see that the presentation is now on Vimeo. But we'll step back a sec. And so all the presentations are available now for you all to watch if you weren't able to watch it on August 8th. And now let's go to the National Academies of Sciences Statement of Task. And I think that would be a good place to start with Tim and David and Ratan and Richard. This is what the Academies is looking at now. They are considering what are the greatest challenges that food and agriculture are likely to face in the coming decades? What are the greatest foreseeable opportunities for advances in food and agricultural science? What fundamental knowledge gaps exist that limit the ability of scientists to respond to these challenges, as well as take advantage of the opportunities? And what general areas of research should be advanced and supported to fill these knowledge gaps? So maybe we should go through the statement of tasks because we based our submissions to the committee on these guidelines or these questions that they are charged with answering. And perhaps we could do a little round robin, but I'll do a very brief introduction of the scientists who are on this call with us today as I pass this question. So how about we start with Tim LaSalle. Tim LaSalle has been our inspiration at Organic Consumers Association and Regeneration International for many years. We first became aware of his good work when he was at the Rodale Institute. And this was around the time that, we knew that there was some connection, obviously, between agriculture and climate. But at Organic Consumers Association, we were focused on the emissions from agriculture. We knew that industrial agriculture had far greater emissions than organic agriculture, but Tim LaSalle at Rodale at the time was coming out with a basis for a new idea, which is not only that by reducing or by transitioning from industrial agriculture to organic agriculture, you wouldn't just reduce emissions, you would actually be able to start sequestering some of the excess carbon from the atmosphere. So I remember learning about Tim's work at Rodale and just having my mind blown to the possibilities. So let's start with Tim. So Tim, you submitted to the National Academies of Science and on this science breakthroughs. And let's begin with your thoughts on the greatest challenges to food and agriculture that we're likely to face in the coming decades. So you have
thank you. I feel humbled that I'm the grandfather to your thinking, Alexis, because Ratan has been at this carbon and soil thing a whole lot longer than I have. But I would say that what I learned clearly at Rodale is they had data and peer-reviewed work, some done by USDA on the site and some done by the scientists there, that had carbon data that certainly started to push the discussion about we can not just move from reducing our emissions but to sequestration. Well, the reason I had gone to Rodale is I had seen three primary concerns that I kept running into globally, and that was climate, hunger, and soil, water shortages globally. And of course, soil carbon addresses all three of those. When we come into Montgomery's focus on soil loss, that brings the fourth element in. Again, the same principles agronomically and working with soils can turn all four of those from losses and degradation into, of course, the positives. So I still say, of course, as we think in terms of soil loss and 60 years left according to FAO, 60 harvests left because of degrading and soil loss and climate, those, to me, it seemed like supersede any other kinds of research questions that we have time to deal with. And Alexis, what strikes me, and after meeting David Johnson a few years ago when Sally Calhoun brought us together, and I had seen Richard Teague's work and a few others, I knew that we were starting to see more robust numbers than what we had summarized out at Rodale. And the other thing that I had been critical at Rodale of, and that why I don't use the term organic anymore, is that when we start to plow and disc our soils, and Ratan's been very much behind the no-till movement, we start to degrade soils as well. So organic soils, and Ray Archuleta is really clear about this, can be worse than conventionally farmed soils. And this is where I've been spending my time, of course, in the regenerative world. But David and, of course, Elaine Ingham and Christine Jones, which reminds me, I owe her a response, better write that down, have, of course, been promoting this paradigm shift away from input, sort of biochemical approaches to soil, to the biological living soils, and how that actually comes into low to no input systems, which I tried and tested my own efforts with Buffett in Africa and found the no input systems on very poor soils, no outside inputs except seed, worked very effectively, tremendously effectively, which of course challenged my own soils classes from way back when, challenged, of course, conventional agriculture. And so when we think in terms of resource shortages, the cost of using fossil fuels to the environment and to the farmer, and the potential for a really low cost, no input systems with what David's bringing forward in his research, and which needs to desperately be replicated in different sites and different soils, because it's the paradigm shifter and moves us away out of our old thinking. Moves us away out of fertilizer thinking, moves us away out of something that for many farmers in the world, for most farmers in the world, becomes unaffordable or unavailable. And so it begins to turn, of course, climate change around very rapidly and turn around fertility and yields too. And thanks for the pictures of your cotton plants, David. That's astounding. And I think that to me, it's the challenge, because it's a paradigm shift. It's like where places like General Mills putting their effort into the Noble Foundation, which is still fertilizer chemical based, is the wrong adage, but it's the old thinking of input-based systems. And we have to make these shifts rapidly because we can't sequester carbon as fast, obviously, when we're repressing that biology in the system. So that's as quick as I can summarize it. And you know, obviously the pasture people, the grazing people, the Richard Teague people are showing how we're getting more carbon in the system than any input thinking could ever imagine in those systems. And so it's affirming this biological realm and its importance for all of us. I hope that responded to what you were looking for.
Yes, that was great, Tim. And I want to share my screen one more time to show everybody what you are up to, Tim, now at Chico State University with the Regenerative Agriculture Initiative. So this is how to find Tim LaSalle today. So let's go back to the statement of task and let's ask Ratan Lal what your first reaction is to the question of the academies. What are the greatest challenges that food and agriculture are likely to face in the coming decades? And Tim introduced you just a bit, but yes, I do want to acknowledge that I believe you are, Dr. Lal, you are the first person who published on the subject of soil and climate change and was able to come up with figures on how much soil could add to solving the climate crisis. Am I right? Your 1998 article was probably one of the first on that subject?
Well, we were asked by the Clinton administration Deputy Secretary of Agriculture at that time, Robert Rominger. He asked us to prepare a report for the potential of US cropland to sequester carbon and mitigate global warming in 1997 for the Kyoto Treaty. And we were a committee of 4, and the book was published and presented to President Clinton at that time. And we had 6 separate congressional hearings on that book. It was entitled Potential of US Cropland for Carbon Sequestration and Provide Other Ecosystem Services. They distributed 10,000 copies of the book. Authors are myself, John Kimball, Ron Follett, and Warren Cole. Warren Cole and I were both members of IPCC at that time. I'm not sure whether that book changed the opinion of IPCC at that time, but it was an important initiative, and Clinton administration at that time allocated $15 million to the carbon sequestration program, which developed into a project called CASM, Carbon in Agroecosystem, its management. The chief coordinator of the CASM program was at Colorado State University. But after that program funding was finished, there were no subsequent allocation to those resources. I already mentioned what was at the meeting. I had the privilege to be present. I want to repeat 4 or 5 points. I did send my written comments to Robin Shane and also to the co-chair of the committee. I believe they were distributed, I'm not sure. But 5 points that I raised. Number 1 was agricultural production must be soil-centric rather than seed-centric. And I made that comment in the context, for example, of why the so-called Green Revolution did not occur in sub-Saharan Africa, because despite the good seed, the soil resources and water resources were not equivalent to elsewhere, such as in South Asia or Mexican regions and other places where soils were fertile and water was added In Africa, and of course the fertilizer were added. In Africa, soils were residual, less fertility. Irrigation still is only 5% of what can be irrigated, and seed alone could not do anything. So soil centering, improving soil health, and one of the indicators of soil health, really the most important indicator of soil health, is of course the soil organic carbon content. Most people believe now that the critical level of soil organic carbon content for good productivity and resistance to climate change, water conservation, increasing use efficiency of input, is somewhere between 2 to 3%. We do not know exactly. It varies from soil to soil, climate to climate, land use and others. But assuming it's 2%, 2 to 3%, let me give you an example of what some of the so-called intensively managed soils have. In the Punjab region, which I mentioned a little bit discussion about burning in the beginning of this program, most soils have under ice wheat system have a carbon concentration of 0.1%, 0.05%. And these are sandy soils. They are irrigated by flood irrigation, fertilizer broadcast, another pesticide and herbicide. Most of it goes straight into the groundwater, drinking water, because the organic matter is not there and the clay is not there. There's nothing to hold it there. And the crop residue is burnt, overgrade, and the dung is used for cooking. Crop residue is also burnt, so nothing gets effectively utilized. So the question of how to restore the soil organic carbon stock in such soils, sub-Saharan Africa, the same situation, is very critical to enhancing productivity. It will not happen unless we all realize that the productive system have to be soil-centric. They have to be based on the principle of improving soil health. And soil health is based on soil organic carbon content, which has been depleted to 0.05%, 0.01%, and has to be restored to 2-3%. Now, depleting soil carbon stock is very easy and restoring is very difficult. And restoring means putting the biomass carbon in the soil more than what is decomposed and eroded and leached. And that reversing the trend, that means the crop residue will be put back. That means the manure will be added back from the land. That means cover crops will be grown. Forages will be grown for feeding to the cattle rather than crop residues. That is going to require change in some policy. That may also require probably payment to farmer for ecosystem services that they generate. So translating this knowledge that we have into action requires some strong policy intervention at the decision-making level. And that is where we have to also begin perhaps to relate, and I made quite a lot of fuss about it at the meeting, that soil health must be related to human health. I indicated many times in the US we have, well, there are 3 parameters of environment: soil, water, and air. We have laws with EPA relating water health to human health and air health to human health, but there is no legislation relating soil health to human health. And unless we can create a legislation where our decision makers are aware of the fact that soil health, plant health, animal health, human health, and ecosystem health is one and indivisible, we really won't make much progress.
That's a great idea. Wonderful. Well, I'll share my screen just one more time to show you all Ratan Lal's website, where you can check out his publications. Let's see here. So all of this is at the Ohio State University website, And all of his publications are here on the site. And it's a lot of great reading, really good stuff. So thank you so much, Dr. Lal. Let's go to David Johnson. Now, David Johnson, we first learned about through the book Soil Will Save Us. And here, let me get back to, I'm sharing my screen. Okay. All right. So David Johnson is profiled in the book Soil Will Save Us. If you haven't read that book, please check it out. It's a wonderful book. And what David is doing is he is creating the best way to use compost for rapid soil carbon sequestration and the multiple benefits that come with that. And David was kind enough to come out to DC from New Mexico to submit public comments at the meeting on the 7th. So again, starting with this idea of what the greatest challenges are for food and agriculture, David, give us your thoughts.
Well, it was a pretty daunting meeting to learn all the population projections and productivity, regression in productivity in our agricultural systems, and seeing that we have to both increase food production per acre and also increase water use efficiency in the system. And we also have to do this in low-income countries to start bringing the productivity back there. We have to do this while competing for limited resources, trying to accommodate the challenges that agriculture gives to the environment, reduce greenhouse gas emissions, enhance the biochemical recycling in all of these processes, and improve micronutrient availability in our soils and foods. So there's a pretty big challenge here, but I think from what I'm seeing, and I think what Tim saw in Africa, the soil biology will be a key influence on addressing all of these. I agree completely with Dr. Lal that 2 to 3% soil carbon is essential. Also, I agree on his projection to pay farmers for these ecosystem services. I think to get them through the transition of how much we've degraded our soils to a soil that actually is fertile and productive, there's going to be a time period they're going to need to be compensated in order to get through. I also agree with him on that soil health must be related to human health. And what we're finding out now in human health, that it's very much dependent on the microbial community that we harbor in our intestines and on our bodies. Everything in our life, they make nutrients that we can't get in our diet. There's over 60 to 70% of our immune system. We're now finding out that they're turning on and off genes in our body, and they affect diseases like Crohn's disease, and even all the way to autism. So, and we're finding out that if we can restore these microbial communities in the human system, that we see the health improve. And I think that it's just a simple step from the microbiome in the humans to the microbiome in soils, and what they're able to do when the soil carbon is up to that 2 to 3%. It gives them enough energy to function properly. It starts helping them improve the photosynthetic efficiency of the system. Of course, as Tim was saying, as we increase that soil carbon, we're also increasing the water infiltration and water holding capacity. But if these systems are functioning properly at a higher percentage of efficiency, they're also photosynthesizing and using that water more efficiently. So all this starts to build on each other. There's several things, that the microbial community does, and realizing how we can start to bring this back in our agroecosystems is critical. That's why what Tim was saying, we need to take some of the research that I've done and start doing it at a larger scale in different parts of the country to see how effective this is. We've seen it work in North Dakota. We've seen it work in Australia. I'm pretty confident that it'll work in multiple places in the U.S. It's just getting the funding to do the research to demonstrate what the microbes can do. And the compost that you were talking about, it's more that we're applying a microbial community instead of compost as a nutrient resource. For so long in agriculture, we've approached it like we have to put all these nutrients in for these plants to function. And yes, for the plant to function properly, they have to be there, but there's no way that we can contemplate and predict what a plant will need because this system is so complex. And yet, plants and their microbial communities have done this for, well, about 4.5 million years. So it's probably be well if we start looking at the soil biology, doing analysis on what the changes and differences are in a healthy and fertile soil where we see proper growth of a plant. We don't really realize how a plant can grow because for so long we've looked at, as Dr. Law was saying, looking at changing the plant to adapt to a poor soil. What we need to do is back up and say, well, let's improve that soil fertility and see what the plants that we have can do. And Tim was talking about the picture I sent him of the cotton that I'm growing on one of the plots that I've brought up to a fertility. And yes, it's pretty impressive to see what a plant that would normally grow knee high is almost head high. Wow. In the right environment. So there's a lot we need to learn from natural ecosystems, how they function and how the microbes and the plants work together in this biological barter back and forth.
Very cool. David, would you like to share any of your visuals?
Oh gosh.
On your computer? If it takes a couple minutes, that's okay. We can go on to Richard. But the photos that I've seen are very impressive.
Well, go on to Richard, and then let me see. Can I pull up a PowerPoint and do part of it, or? Okay.
Yeah, whatever you see on your computer, when you hit share screen, we will see.
Okay, I'll work on that. You can talk to Richard.
All right. Well, Richard, we've been going around looking at the statement of task from the National Academies, and the first question that they are charged with answering, which is, what are the greatest challenges that food and agriculture are likely to face in the coming decades? So let's hear your thoughts on that, Richard. This is Richard Teague. He's at Texas A&M, and he is doing what David is doing for crops, Richard is doing with livestock, and he is discovering and documenting the greatest possible carbon sequestration in livestock management techniques. So Richard, take the floor.
Thank you. Thanks for the opportunity, and thanks for getting me up there, which is a very interesting conference. The outlines by Tim and Ratan are a perfect background for me to fit within. David also fits well in with that, as he said, basically on the cropping side, and I've been working on the same concepts with the same thinking on rangelands and grazing ecosystems. Grazing systems are really important because they cover about 30% of the land area, terrestrial land area, and the ecosystem services from them are fundamentally important, and the value of those ecosystem services far exceeds that of the agricultural earnings on them. So there are many reasons to look after it well, and I've concentrated not just looking at the climatic stuff, but looking at the complete suite of ecosystem services that we require as human beings to thrive into the future. And I found that where most of the rangelands and grazing lands that we're dealing with are degraded, not just in terms of depleted soil, as has been outlined, but also the general biology and cover of plants of the soil. So the soils are very degraded in these areas as well. But the good thing is that there are many outstanding ranchers who've restored ecosystem function and profitability. And they've done that by aiming to increase their soil health as a platform to increasing their profits. And wherever we've measured from here, Texas, right up into Canada, west in dry country, and also east of the Mississippi, we found that we're getting increased carbon sequestration and increased infiltration and soil fertility at the same time, wherever we've looked at it. Now, climatic conditions dictate how much of an increase is made, but we're getting the same response throughout. And as you know, we've got a multidisciplinary project to start looking at the causal mechanisms of that and how we can alter our management to actually improve those causal mechanisms and move things forward. A lot of research that's been done in this area has been done with continuous grazing. And because the scientists have ignored the impacts of scale and the length of time it takes after instituting really good management, they have totally underestimated the amount of carbon that can be put in the soil. And that is exacerbated a lot by the fact that they've only measured down to about 30 centimeters. And we measured down a full rooting depth in our study, and our new research is down at least a meter, limited by logistical constraints only. So we're looking at how different management impacts the 4 ecosystem processes: the capture of energy, the water cycle, the mineral cycling, and the requisite biology of the soil and the plants that drives those things in the direction that we want. And we found what we call AMP grazing, which is holistic plan grazing. It does a very good job of that in every ecosystem that we've studied. And one of the things that people are worried about is the emissions from ruminants. And we found every place we've looked at it that the amount of carbon being sequestered, even under moderately poor grazing, still exceeds the amount of emissions from the cattle itself. And that doesn't even include the work like the Australians have done on termites, where there are natural processes in the atmosphere that actually break down the GHGs emitted from the soil very, very quickly. We haven't even considered those in, and we still are putting more carbon in the ground than the emissions from the cattle alone. But of course, the major damage in all of the ecosystems we talk about, cropping and agriculture and grazing, is when you start looking at cropping agriculture, which involves tilling and putting on inorganics and pesticides that really mess around with the driving biology in the soil. And in the grazing lands as well as the crop lands, as has been discussed earlier, we've got to get away from those things that cause the breakdown in biological function in order to reverse the soil organic carbon declines and start getting gains. And everything that we're doing in the grazing really backs that up. To come back to some of the discussions that we heard in DC, it was disturbing to me being there, because it's like me going back to campus on Texas A&M and listening to all these guys who in total, they just will not admit that there's anything that they're doing that's wrong to the environment. And generally, they do not understand the story that Ratan has championed, that we really need to improve soil health in order to start moving things in the other direction. And right at the end, one of the people who was summarizing actually summed it up quite well. He said, we've looked at the economics, the cost benefit of all the research that's been done in agriculture, and there's a 20-fold return on every dollar that we spent in research. But they have not included any of the negative unintended consequences that we know occur in agriculture. And one of the talks towards the end of the day actually had a very good diagram of the dead zone in the Gulf of Mexico, which really shows the kind of damage that we have done. And until you start including the damage caused, as illustrated by that the dead zone, in a proper comprehensive life cycle analysis, you absolutely cannot make the statement that for every dollar we put into research, we gained 20-fold, because quite the converse is probably true. And I'll stop there. Thank you.
Well, thank you so much, Richard. While you were speaking, unfortunately, I lost the call on my computer because my computer crashed, but I am signing back in, and I'm on the phone for the meantime. So just one moment. In the meantime, could you all take question number 2 from the National Academies? Or we could, if David's ready with the photos that he wanted to share, we could do that. And it looks like, Ratan, you're sharing your screen right now. Did you have images that you wanted to share with us?
I don't know how to make it a lot.
To the right. To the right.
So Ratan, if you see,
I'm trying to get my screen back. Did you have a question for me?
Ratan, did you want to show something on your screen with the group? Did you have an image to show with us?
Do you have anything?
No, I do not.
Oh, okay. Great. So we need to get you out of screen share. And David, are you ready to share your screen?
Yes, I can.
Okay. Why don't you try sharing your screen and we'll see if that takes over.
Okay.
It's on the very bottom, screen share, and then you'll have to hit the blue button on the right, share screen, in the pop-up window.
Okay. I guess it's not.
Sorry, that's me. He may be sharing his screen here.
Is this it?
Not being shared.
More this.
Yeah, just move that.
There we are. You're live.
That-
Your screen is live.
Oh,
Yes.
good. Enough buttons to push there. This first picture is James Bearfield, Los Alamos Laboratories. We're working with him, looking at characterizing soil carbon with laser-induced breakdown spectroscopy. He just happened to be out there on one of the trials that we had looking at the BEAM approach, which is the biologically enhanced agricultural management, where we focused on bringing or restoring the soil biology compared to a conventional cotton crop, 150 pounds of nitrogen per acre. And the BEAM had been going in process for 1.5 years. We saw significant improvement. No fertilizers are used on the BEAM process, just biology, just restoring that soil carbon, restoring the biology along with it. As you can see there, there's a significant difference in growth. This is this year's cotton on July 17th. This is what the cotton looked like. This is one of my BEAM plots. This is August 2nd. And this is August 17th, 1 month later after that first picture. As you can see, the cotton can grow significantly well in a BEAM soil without fertilizers. And cotton is one of the dirtiest crops on the planet. It uses more fertilizer and more pesticides than any of the others for what you get out of the growing process. Also, in some of the cover crops, on the right-hand side, that's a black oilseed sunflower. Normally, they only grow 4 to 5 feet. The heads are usually about 6 inches. As you can see, here it grew about 7 feet, and the heads were bigger than mine. On the left is a Sesbania cover crop that I use. It's a summer cover. It's a legume. It also associates with mycorrhizal bacteria. And then you can see significant growth in that. First season we grew it, it was about 4 feet tall. The second season was a little over 6 feet tall. And in this particular growing, some of them were over 12 feet tall. So we're able to see that constant improvement in the soil as we start to put the carbon back and start to build up the soil biology. And that's why I'm saying we really don't know what plants can do with the right soil fertility. So it might be a good idea that we start looking at this, as it answers so many questions and so many problems that we have. As far as carbon goes, on this plot, we've averaged about 10.7 tons carbon per hectare per year increase. Now that's significantly more than others, but when you compare it to what Gabe Brown is doing in North Dakota, he's putting it in at double the rate that I'm putting it in. So he's putting it in about 0.5% a year, and I'm at just a little over 0.25% increase in soil carbon per year. So biology does make a difference in how all this works, and that's why we need to start looking at this as regenerative and move away from thinking that we can contemplate every nutrient a plant needs and put it out there, into allowing the system to start functioning properly and make the decisions for us. I'll get out of screen share now, or try to.
No need. Those are beautiful photos. It's so exciting to see your successes. This is incredible and wonderful. Well, Ratan, you were sharing your screen a bit ago, and I was wondering if you might try again and find the paper that you were telling us about at the National Academies of Sciences meeting. Dr. Lal, you blew my mind when you started talking about how we don't actually need all of the land that's currently in production to either feed our growing population or to sequester the carbon that's in the atmosphere that we need to draw back into the soil. So I'd love for you to share that.
That is correct. And I published an article, I can send it to you for distribution if you so wish. And I indicated that we could feed the world population, present and future, by reducing the cropland area, actually, not increasing it, as long as we restore the health of the soil. And I think our strategy should be not increasing more and more input of land area and water resources and nutrients and pesticides, but decreasing them by improving soil health. And I think that was, so the article that I had, it was published in Journal of Food and Energy Security, indicated that rather than 750 million hectare of land area under cereals, we could produce even more than what we are producing now by 500 million hectare of the land. And the extra land should go back to nature conservancy, carbon sequestration, and biodiversity improvement. One thing which you should also remember, and it was brought up a couple of times at the meeting, that 95% of the enzymes of the antibiotics taken by humans and animals actually come from microbes in the soil. So we do not want to destroy the pristine, undisturbed natural soil ecosystems all over the world. We should preserve them for many other ecosystem services that we may not have even discovered. And because of the contamination of soil by even antibiotics taken by application of elements that contain these antibiotics, we really are finding it very difficult to find pristine soils. So preserving soil resources for other ecosystem services and producing more from less, and that philosophy of producing more from less by sustainable health, by improving soil health. And I think microbial processes, rhizospheric processes, are very critical to that. Soil organic carbon, which is not only for water retention, for denaturing pollutants, for biodiversity, is also food for microbes and soil biota. So having that organic carbon concentration restored through efforts of recarbonization of the biosphere is really quite critical. So the idea which I get very concerned when I hear, even by well-meaning international organization, saying we need so many million hectare more to feed the world, I think that's a wrong strategy. We should produce more from the best and save the rest of the land for nature.
So I have questions for you about this, and the other panelists chime in if you also want to join this conversation on this topic. But Dr. Lal, so part of what would happen is we would use land more efficiently. So rather than growing crops to feed animals, have animals just grazing and then using all of our cropland to directly feed human beings. Is that one of the ways that we can use less land in addition to improving soil microbiology?
Well, we need to improve soil health. That's for sure. I'm not saying that we do not need animal-based system. No, animal-based. In fact, animal system should be integrated with crop system wherever possible. As far as the diet is concerned, I think there is certainly important role animal can play in human diet. Milk, cheese is other products which are quite important, which we can't ignore. But certainly legumes can play a very important role in protein. I just published an article in Advances in Agronomy, which was based on a talk I presented at the International Year of the Pulses last year at ICARDA. And the idea was to probably put more emphasis on pulse-based diet. Some of the legumes, mung bean, the urdu bean, Phaseolus mungo, its protein content is pretty highly balanced. So I think we cannot ignore that. Feeding 11.2 billion people on a lesser land area is going to require all aspects of producing nutritious food. But I think the main part, it still is that nutritional security has to come from improved soil health, not necessarily from the pills. Although our panel, one of the panel at the meeting, National Academy, was human nutrition, and I did want the attention of the chairperson, but I didn't succeed in that. The human health aspect in relation to soil health is not limited just to nutrients like iron, manganese, zinc, iodine, molybdenum, selenium. It is
Maybe Ratan had the same problem I did. I hope his computer didn't just crash while we were in mid-sentence. But this is a pretty incredible forecast that we can actually do more with less, use less land in production to feed human beings even as our population grows. Let's get a response from the other panelists. How about Tim LaSalle? Would you like to respond to this? Is what Ratan saying, does that match what you can, okay, sorry. Let's go back to Ratan, he's here again. Well, I was going to let others comment, but I want to let you finish your thought. When you were talking about what you wanted to say to the nutrition panel.
Well, I wanted to mention that the soil health in relation to human health goes beyond the micronutrients. That part is important, no question about that, but it's more than that. It's the microbial processes also, the rhizospheric processes in soil health, which are very important to human health and human nutrition. And that part was not properly addressed by the panel. In fact, it was ignored.
Oh, this is Tim. Ratan, I would love to see a copy of your paper on that with regard to feeding more people on less land.
I'll send it to you.
Alexis, please, yeah. Alexis, I do have a comment on that because that's my experience, that's my bias, and that's certainly what I promote. And I'd love to see Ratan's analysis on that. I think it would be very, very positive. In Africa, within 1 year, on very poor soils, they increased the yield on maize 5 times. And so went from a ton to 5 tons. And so when you do that, and you think in terms of who's mostly food insecure, it's typically rural people, particularly on the African continent, that have land access. And if they could move their maize production from less than 1 ton to over 5, you start to not only solve that, you feed a lot more people very rapidly. So what he's saying to me resonates as an experience for me, not just an extrapolation of numbers, that I think Ratan's has obviously contributed a very, very important piece in this. I wished it was a debate. It actually isn't a debate in today's world, because the promotion of the idea that we need 70% more food for 30% more people doesn't even make any sense by its numbers, but it's what's being promoted as what needs to happen.
Yeah. Tim, I want to mention that the average yield of cereals in Africa in the 60s, when I just started my work at IITA, was 1 ton per hectare. And 40 years after, the average yield of some cereals, corn, sorghum, millet, upland rice, is still about the same. And it's not because we have no improved seed. In fact, CIMET, CIAT, IITA, ICARDA, and other will tell you that they have 100% improved variety. It is that even the improved varieties can't draw nutrient and from a soil where they do not exist, or water from a soil where they do not, because the soil health is not very good. So there is no question that the yield in Africa of cereals and beans and other crops can be easily quadrupled with the technology that we know since 40 years. But the technology has to be soil-centric. And therefore, it's not an idea of clearing more forest and destroying additional land. It's really using the existing land properly with the technology that we know. And that message we have to really put across very strongly. The paper, I will send it to you, it actually shows what the existing yield is in a region like Africa and South Asia under dryland agriculture, and what it can be so that the area can be spared and put back for nature conservancy.
Ratan, I've got a question. Could you confirm that that is without inorganic and pesticide inputs?
I really did not go into that, and I do not really want to go into that. The reason is, for me, I believe in integrated nutrient management and integrated pest management. I tell you what that word integrated means. First, you recycle, do biological nitrogen fixation, mycorrhizal. Compost is a very good disease suppressing material that's a proven. We had a plant pathologist at Ohio Agriculture Research Development Center. His work goes back to 30, 40 years, 25, 30 years, indicates that well-prepared compost will suppress plant diseases. So integrated means, okay, if you need 150 kilogram of nitrogen to produce 200 bushel of corn, let's first see how much will come from biological nitrogen fixation, recycling, compost, and if we need to supplement by chemical fertilizer, I have nothing against it, as long as the plant ability to grow can be met. It is the indiscriminate use which is really a problem, and the excessive. Let's take North China plains, 600 kilogram of fertilizer. That's outrageous. While they could get even better yield by decreasing down to 100 kilogram if they were to supplement by other means. So my concept is judicious use, integrated use. Do not destroy soil resources, but build upon soil resources. I do not draw a rigid line, thou shalt not do this, as long as the concept of improving soil health is maintained.
Yeah, thank you. I just wanted to understand what you based it on.
And Richard, do you have further thoughts on this concept, this idea that we can grow more food for more people with less land? Does your research also bear this out?
Yes, it does. If you look at the improvements, it's not uncommon for people after using planned grazing well for 4 or 5 years that they produce 4x what they started off on. And the better producers within 8 years will be 6x where they started. And it changes the whole dynamic and brings extra business possibilities into account. But there's another aspect to this too. In many areas in the developed world, where people just live off the land, basically on livestock, they have trouble growing vegetables and getting vegetables and stuff for a decent diet. And if you herd the animals, you graze them out and bring them back in again around the house and manage where they put their dung in a rotational system around where they live, they can start producing because the soil health has improved around their houses to have really good gardens without any expensive inputs at all. It's just managing the biology of what they got. And that would fit into the same sort of scenarios as Lala's talking about.
Richard, I wanted just to mention something along that line. In Catherine, in Australia, I guess many of you may know, I visited that division of pastures from Brisbane several years back, even in the 60s when I worked there. They developed a system called lay farm. The lay farming system was where the forages are incorporated within the cereal crop rotation, and they are grazed judiciously so that it's the integration of livestock with crops which would maintain a balanced system of soil and water resources management. Same thing applies to small landholders in Asia and Africa. I think the lay farming system that came out from Brisbane and the Catherine experiment stations in 70s and 80s is more scientific, but everywhere small landholders, they have cattle either for draft power or for milk or for other purposes. So it's the integration, and that integration shouldn't stop at animal and grain crops. It should really be also extended to perennials such as trees. So it could be silvopastoral system or agro-silvo system or agroforestry system or agro-silvopastoral system, if we can manage them properly. And in that kind of system, which sometimes is not conducive for large-scale agriculture, but we have 500 to 600 million small landholders around the world, that's the way to reduce the inputs of chemicals. And that's where you increase productivity per unit area and unit time more properly. It's the integration that requires more scientific knowledge and skill. Expensive, increasing area is the easier and more destructive way to do it.
I concur. I've seen the same thing around the world. And those lay systems were based on the early 1900s work that had been done on biological farming in Europe. And the Aussies had done very well at making it applicable to their local, more tropical areas.
Great. And David, I'll give you the last word on this topic, although your photos seem to speak for themselves.
Well, it's other people's work also this can be pulled in this. From what Ratan was talking about, I agree with him. Again, 100% use the existing land that we have better. Restore that fertility. In Australia, they're doing what he was just talking about, the grazing mixed with farming. They're doing an early season wheat crop, and in an area in Western Australia that gets very little rain, down to like 4 inches in some other seasons. And they're applying biology to the soil. And Dr. Law was talking about having the right compost. And again, I would agree with him completely there, having a mature, biologically diverse compost. They're putting it on their wheat fields and barley fields at a rate of 1 kilogram compost per hectare. So they're doing an extract of a good, healthy compost, and they shoot it into the furrow as they plant the wheat or the barley. In that region, they normally get about 1.6 tons of grain per hectare. And with the biology, they're seeing 3. The farmers that are around this couple there that have been doing it conventionally have gone out of business. And these people have gone in and bought their land, and they've started with the biology, and they also incorporate grazing of sheep after they bring that wheat crop in. So they're mixing these systems. And seems like there's a common theme from what Tim saw in Africa, 5 times increase. And Richard, what he's seeing in the grazing, a 4 to 6 times increase. I'm seeing a 4 to 5 times increase in productivity in the soils that I'm working with. So there's a recurring theme here about, yes, we can grow more food on less land. And if we can grow twice the crop on the same amount of land, that means we're going to be using half the water. So that starts to solve that water issue at the same time. There's so many benefits on this that there's no reason why we should not start to pursue this. I know the farmers have trouble making a transition, but it would be a good investment in our future because it's going to be a system that eventually becomes self-promoting. You will no longer have to subsidize it. And once you bring these soils back, so many issues we solve as far as our environment, as far as the downstream pollution of our rivers, lakes, streams, aquifers, oceans, from all the fertilizers that we've been using. And we can start reducing the herbicide and pesticide because, again, what Dr. Law was saying, seeing how a compost can help a soil be healthier, be more resistant to pathogens. I see the same thing in my research. It's like what's working in us. We have probably 10 microbes in our body or on our body to every 1 cell in our body. If they didn't like us, we wouldn't be here. They're there for our benefit for the majority. And they give us the competitive inhibition of the pathogens that are on us, around us every day of our lives. So it's realizing what we're seeing in the human microbiome and the human microbiota, translating that into soils. The benefits will solve many of the problems that we have right now.
Hear, hear. Well, I hope that everyone who's watching will go to the Science Breakthroughs site, and they have a link there to IdeaBuzz. That's the program or the website that they're using to collect public comments. And so Richard Teague and Tim LaSalle and David Johnson all submitted white papers through IdeaBuzz, and then you can vote for them. So here's Richard Teague's, and I should be able to find the others. Let's see.
I think mine's number 13 on the list.
Lucky number, David.
Always.
But number 1 in terms of hits.
We can thank Wayne Yin for that.
So your submissions are doing well. I was a little bit afraid that that regenerative agriculture wouldn't get as many votes as lab meat, but it seems like it's doing well. So let's keep up that trend, and there will be more opportunities for interacting with the National Academies of Sciences. They're doing another committee now, and it's to develop a research agenda for carbon dioxide removal and reliable sequestration. And I guess this won't be quite as exciting as the food and agriculture discussion, because when you talk about food and agriculture in this context, it's not just carbon sequestration, it's also the multiple benefits that you all shared today, from improving our own healthy microbiology in our guts, to creating nutritious, nutrient-dense food, to really ensuring food security for small-scale farmers who don't have access to expensive seeds and inputs. So this might be not quite as exciting, but it's still very important to engage on this issue just for the climate change debate. And it's exciting, actually, to see this becoming central in the climate change debate. The National Academies begins here by pointing out that we can only accomplish our climate goals now with negative carbon emissions. And as far as I know, we've got, all these various ways that they list to sequester carbon, but the terrestrial biosphere is where it's going to really happen, from what I've learned from the scientists who have joined us today. So thank you for participating. Thank you to Regeneration International for supporting these trips for the scientists to go from where they're working to Washington, D.C. to engage with the National Academies. And I urge you all to stay engaged. Thank you all so much.
Thank you, Alexis.
Hi.